Good morning, student. Today we are going to learn about sampling theorem, sampling techniques, Nyquist rate and aliasing. After the completion of today's session, you are able to define sampling theorem, classify sampling techniques, define Nyquist rate and aliasing, and solve related problems. So first we discuss about sampling. A continuous time signal may be completely represented in its samples and recovered back if the sampling frequency is fs greater than equal to 2 fm. So sampling means the process in which a continuous time signal converts to discrete time signal. Okay, so here we take a continuous time signal, then multiply that signal with a pulse train. This one is the pulse train, and the frequency of this pulse train maintained at fs, means that frequency is known as sampling frequency. Then fm is the maximum frequency present in this signal. Okay, so the condition should be maintained that sampling frequency should be greater than equal to twice of maximum frequency. Okay, so after sampling, if we try to recover back the same signal, it properly recovered back only if it satisfies this condition. Okay, and for sampling we use a multiplier. That multiplier multiply the original signal, this one, with a pulse train, means this one. We multiply these two signals and at the output we get this one, means the continuous signal is converted into a discrete time signal. Next, so how we can find the maximum frequency of a signal? If a signal contains various frequencies, then how we find out the maximum frequency? For example, if this one is a signal, then see here, sine 2 pi t plus sine 3 pi t plus sine 4 pi t, means here three frequency components are present. So we know that sine omega t, this one is the representation of this all. So when here three frequency components are present or three terms are present, so first one is omega 1. So omega 1 means this one and this one, 2 pi. Okay, so as we know, omega is 2 pi f1, so equal to 2 pi. Then f1 equal to 2 pi by 2 pi, means 1. Okay, so first frequency is f1 equal to 1 hertz. Okay, then second one, that is omega 2 equal to 3 pi. So 2 pi f2 equal to 3 pi. Pi cancelled out, f2 f2 equal to 3 by 2, that is 1.5. So second frequency is 1.5. So f2 equal to 1.5 Hertz. Then third frequency, that is omega 3 equal to 4 pi. So 2 pi f3 equal to 4 pi. Pi cancelled out. Then f3 equal to 4 by 2. So it is 2. So f3 equal to 2 Hertz. So among these three frequency component, which one is the maximum? That is f3. That means for this signal, f3 is the maximum frequency. So if someone asks you that what is the maximum frequency in this signal, then you can say f3, that is 2 Hertz. So 2 Hertz is the maximum frequency in this signal. This way you can find the maximum frequency of a signal, then set the value or set the condition, that is fs greater than equal to twice of 2 fm. Okay. Next, types of sampling. Sampling classified into three types. First one is the instantaneous sampling, means ideal sampling, then natural sampling, then flat top sampling. So the first sampling is instantaneous sampling. In this type of sampling, the sampling function is a train of impulses and the width of the pulse approaches 0. So if we consider the width as tau, here we can see tau is equal to 0. So when we multiply the modulating signal with this impulse signal having pulse width 0, at the output we get our instantaneous samples, where the pulse width value is 0. So this type of sampling is considered as ideal sampling, and to generate ideal sample train we use switching sampler. As the pulse width is 0, because of that practically this type of sampling is not possible. Okay. Next is the natural sampling. So natural sampling is a practical method. In natural sampling, the pulses has a finite width equal to tau, means these pulses are having the width which is denoted as tau. Okay, so here we use finite interval pulses. Noise interference is less due to finite interval pulses, and in input of the multiplier we give two signals, means these two signal, one is the continuous signal and another one is the pulse train. Then multiply these two signal, at the output we get this natural samples. Why it is natural sample? Because the age of these pulses are increasing or decreasing as per the amplitude increases or decreases in this signal. Okay, and this method is used in practical methods. Next is the flat top sampling. So in flat top sampling, the top of the samples remain constant and is equal to the instantaneous value of the input signal or continuous time signal, or we can say modulating signal. So this one is the pulse train, and here also we use finite interval pulses, and the width of the pulses are denoted as tau. Okay, when we multiply these two signal, at the output we get samples whose top is flat. Because of that, the sampling technique is known as flat top sample. And the amplitude means when it converted into samples, it take the value of the starting pulse and maintain throughout the width of the pulse, means like this. Okay, here if this one is the starting of the pulse, then it maintain that value throughout its pulse. Okay, so like this we get our sample. Next is the Nyquist rate. So when the sampling rate becomes exactly equal to 2 FM, means twice of maximum frequency, then it is called Nyquist rate. Nyquist rate is also called the minimum sampling rate. So sampling frequency is equal to twice of FM. So it is the minimum sampling rate, and the Nyquist interval is Ts equal to 1 by 2 FM. As we know, time is represented as T equal to 1 by F. So 2 FM is the frequency. So in place of F we place 2 FM. Okay. So this is all about Nyquist rate. Then aliasing. So when we violate the condition of Fs greater than equal to 2 FM. So if we violate this condition, then it becomes Fs less than 2 FM. Then at this condition, aliasing occurs. Aliasing means when a continuous time signal is sampled at a rate lower than the sampling condition, then the successive cycles of the sampled signal get overlapped with each other. Means we want to get a signal like this, but if it violates the condition, then it gets overlapped with each other. Because of that, we never get a proper output or proper information. Because of this, some information may lost. Okay. Next is the some related problems. So find the Nyquist rate for the signal x of t equal to 3 cos 50 pi t plus 10 sin 300 pi t minus cos 100 pi t. So from this, first we have to find the maximum frequency of this signal. So W1t equal to 50 pi t. So equal to 50 pi, 2 pi f1 equal to 50 pi. So pi cancelled out, 2 and means here we get 25. So f1 is 25 Hertz. So first we write down f1. F1 equal to 25 Hertz. Next is the W2. So W2 equal to 300 pi. So 2 pi f2 equal to 300 pi. So pi cancelled out. f2 equal to 300 by 2. So 150 Hertz. So f2 equal to 150 Hertz. f2 equal to 150 Hertz. Then last term or third term equal to 100 pi. So 2 pi f3 equal to 100 pi, that is f3 equal to 50 Hertz. Means pi cancelled out, 2, this one is the 50. So f3 is 50 Hertz. f3 equal to 50 Hertz. So from these three components, what is the maximum frequency? This one f2 is the maximum frequency. So if we get the maximum frequency, we know that fs equal to 2fm. So fm value is 150. So fs equal to 2 into 150. So fs equal to 300 Hertz. Then Nyquist rate is 300 Hertz. This is the answer. Okay. Next problem is find the Nyquist rate and interval for the signal x of t equal to 1 by 2 pi cos 4000 pi t into cos 1000 pi t. So first we have to convert this signal into a plus or minus terms. For that, here we apply the mathematical formula, that is cos A into cos B. So cos A into cos B equal to 1 by 2 cos A plus B plus cos A minus B. After applying that mathematical formula, we get x of t equal to 1 by 2 multiplied here. So 4 pi cos A plus B means 4000 plus 1000, 5000 pi t plus cos 4000 minus 1000, 3000 pi t. Then you can easily solve. In first term, the omega 1 equal to 5000 pi t. After solving, we get f1 equal to 2500 Hertz. Then in the second term, 3000 pi t, that is omega 2. After solving that, we get f2 equal to 1500 Hertz. So in these two terms, the maximum frequency is f1. So the Nyquist rate fs equal to 2fm means 2 into f1, that means that is 5000 Hertz. Okay. Then Nyquist interval means 1 by fs. So 1 by 5000 equal to 0.2 into 10 to the power 3 second. Okay, so properly solve this question, I just do in a shortcut manner, so properly do it. If you face any problem, ask me. So this is all about today's class. Thank you.